Enumeration. If you recall, we talked about simple data types at the very beginning of the semester. Our integrals, our ints, our chars, our floating points, our floats, okay, our doubles, captures, decimal places. Today we're going to talk about enum. Enum is where we'll create our own simple data types. Enum is where we'll create our own simple data types. If you look here, this is our general syntax for enum. We say and use the keyword enum and then the type name, meaning instead of int or double, the type name that we give it, because we're creating the simple data type. And then we have here value 1, value 2, which is basically these are the identifiers. These are the identifiers known as enumerators. Note here that when we listed in this format here that we're specifying a particular order. We're specifying a particular order where the very first value is defaulted to 0, and then 1, and then 2, and so forth. These are not variables. They are not variables. All right? They are not variables. Operations on enumerations. No arithmetic operations are allowed on enumerators, nor can you increment or decrement enumerators using operations. You can increment the value of an enumerator by using the cast operator. What we mean by that is that if you are in the very first value here, you can push it so that you're now at value 2. So you're not adding anything to it like you typically would with an increment operator, you know, +1 or something like that. You're just simply pushing your ordering from value 1 to value 2 if you were on value 1 to begin with before you issued the cast operator to increment the value. You can use relational operators on enumerators because at the end of the day, okay, they do have a default value. Value 1 is 0, value 2 is 1. In other words, this could be blue and this could be red, but their values are 0 and 1 based upon this ordering here. And thus what you can say, blue, red, where blue is greater than red, well, in this case, blue is 0, therefore it's false. That's how you can use relational operators on enumerators. Enumerators input-output. Input-output is done indirectly. It's done indirectly. All right. C++ only accounts for input-output with your integral floating points in terms of simple data types. So with enumerators, you have to input-output indirectly. And I'll show you that later. All right. If you directly output the value or output an enumerator, what will output is the value assigned. So if this was blue and this was red from our earlier example, the actual value is 0 and 1. And therefore, if you were hoping to print out red, what you would really print out is just 1. Enumeration functions. When using enumerations with functions, you can, like before with an integer, etc., you can return the enumeration type. You can also pass by value or reference the enumeration type. Let's look at an example. So here's our enum example. Everything looks familiar here. Check this out. We're going to define a new data type called spells. Enum spells. Our enumerators are Isio, Expelliarmus, and Lumos. Values 0, 1, 2. After we create our new data type spells, I'm going to declare the variable for it. So here's our data type spells, like it would be an int or a double, but now it's spells. And here's our variable, Harry Chant. Next, I say spells, get chant, and void display chant, because I'm doing a function prototype here, meaning I've got my functions down here, if you recall. And because I'm listing them down at the bottom, I need to list two prototypes up here at top. I have int main here, char chant, cout, Harry's about to duel with Draco. Enter in the first letter from one of the following Harry Potter chants: Asio, Expelliarmus, or Lumos. All right. Cn chant, and then I have get chant chant. So here's our actual parameter. It's going to be an A, E, or an L. Go down to the get chant function. Here's my formal parameter, char selection, switch selection. So it's going to either be an A, E, or an L. And this way I captured both the capital case and a lowercase. And if it started with an A, it'll be Assisio, E, Expelliarmus, L, Lumos. Whichever one case it is, it'll capture it and then it'll return it, because enumerations can be returned. So once it's returned, it comes back up here to, don't worry about this right now, I have it commented out. Display chant, Harry chant, which was right here. Display chant's another function. So here's our void display chant spell selection, switch selection. So let's just say it's Assisio. If that's the case, it will see out Assisio and then break. All right, because remember, IO is done indirectly. All right, if I directly printed out Assisio, in this case, what I'm printing out would be 0, 0, 1, 2. But I wanted to actually say Assisio, so therefore indirectly I had to use this function to spiel out Assisio. Let's go ahead and run this. So Harry's about to duel with Draco, entering the first letter from which one of the following Harry Potter chants. So let's just say Harry says, Expelliarmus, E, and there he goes, Expelliarmus. All right. Now, if you recall, operations on enumerations, you cannot use the increment or decrement operators on enumerators. However, you can use the cast operator. You can use the cast operator to increment the value. Here are our values, our enumerators. 0, 1, 2 are our values. So although you can't say plus plus, you can use the cast operator to push the value forward. So here, Harry chant equals, to push it 1 over. So let's go ahead and run this. So here I'm going to say E, and rather than saying Expelliarmus, it says Lumos instead, where Harry Wands just simply lights up. And Draco, of course, applies successfully his bugger spell on Harry.